Okay, so this is the first lesson in the gas laws unit. We're going to go through this virtual lab together. Hopefully you have noted that you're supposed to compare pressure, temperature, and volume of ideal gases, which is a special situation, but we are just beginning to think about it. You should have already done your bell ringer, and we already watched this video. So if you want to open this link, you may. If you would rather not, I will go through it in this video. These are the questions that you'll be responsible for. So let's go ahead and read the questions first before we begin, and then we'll look at the virtual lab. How does the pressure change when you change the number of moles? So in the bell ringer, we talked about moles as an amount of atoms. So how does the pressure change? If the volume is fixed or stays the same, how does the pressure change if the temperature is increased? So we'll go through each one as we go through the virtual lab. 3 says, what does the graph look like when you change the volume? What is the graph telling you? So we're going to have to read a graph. What equation is used in the simulation? What pressure is achieved for 1 mole of helium at 150 K in 1 liter? Well, that's a lot of numbers. So we'll have to make sure and be really specific and look at that. And then what pressure is achieved for 0.5 moles of helium at 150 Kelvin in 1 liter? So I am going to go ahead and pull up the virtual lab. I'm going to pull the questions over, and we will just walk right through the questions together. So we can see, let's kind of check out the virtual lab first. We see a formula down here. We're not ready for that yet. We just need to acknowledge that that formula is there. We've got gases, looks like helium and argon, volume, inverse volume, temperature, and N. What was N? Do you remember from the video? N stands for number of moles, so that amount of atoms that we're looking at. We have some bars that we can change them. All right, let's go through our questions. The first one says, how does the pressure change when you change the number of moles? So if I want to change the number of moles, I'm going to look at the pressure over here. Here's number of moles versus pressure in my graph. And if I go, it looks like I can go backwards. Let's see. At 0.5 moles, my pressure is at 12 ATMs. Okay. If I increase my moles to 0.7 moles, my pressure is at 16.8 ATMs. So what do you notice? As the moles go up, what happens to the pressure? At 0.9 moles, we're at 21.6 ATM. What do you notice? Well, show me with your finger. Does the pressure go up or down if the moles go up? Right. As the moles go up, the pressure goes up. So we have more stuff in there, more pressure. Notice they're flying around, hitting each other. That is what is increasing the pressure. So that's number 1. As the moles go up, the pressure goes up. You could type that right now if you want to. Number 2. If the volume is fixed or stays the same, how does the pressure change if the temperature is increased? All right, so this time we are going to look at volume. Now, volume is going to stay the same, so we want to change temperature. So how does the volume? The volume is going to stay the same at 1 liter. If the volume is fixed, that's what we got. How does the pressure change if the temperature increases? All right, so let's make the temperature, well, look at that. If my temperature is 150 kelvins, my pressure is 10.8. This graph shows us the direction of change. So notice my temperature is 177.2 kelvins. My pressure is 12.76. Show me with your finger. As the temperature goes up, what's happening to the pressure? Yeah, we can see as we continue to move the temperature up, 2.435 Kelvin, so 243.5 Kelvin is the temperature. We have 17.53 ATMs, which is our pressure right here. So as the temperature increases, the pressure also increases. All right, that was number 2. I would type that right now. look at number 3. What does the graph look like when you change the volume? What is the graph telling me? Well, I can't change the volume unless I change my choices over here. If I change my volume, well, that's a different graph, isn't it? I look at this graph over here, and I can see it's a very different graph. Make my volume very small. My pressure is at 21.6. So 1 liter, my pressure is at 21.6. If I make my volume bigger, what happens to my pressure? My volume is 1.4. My pressure went down to 15.43. So show me with your finger. As the volume goes up, what way does pressure go? Down, right? As the volume goes up, that pressure goes down. At 2 liters, so twice the amount of spaces we started with, we have only 10.8 ATMs. So the pressure is 10.8. So we could say that as the volume goes up, the pressure goes down. Why is that, do you think? What do you think, Chris? Go ahead, Chris. Exactly. These little atoms in here are running around like crazy. They're gas molecules. They have loads of energy. And if they have more space, they're not running into each other. Okay, they're not hitting each other as much. And that's what makes the pressure go up, is these particles inside hitting each other. All right, so let's look at number 4. What equation is used in the simulation? So all we got to do is write it down. Cool. This right here. So when you type that, you're going to type P equals, and then put that top part in parentheses. So parentheses, N times R times T, parenthesis, the end of the parenthesis, and then like a divide or the slash V, so that everything in the parenthesis is divided by volume. Okay. All right. So then we have number 5. What pressure is achieved for 1 mole of helium at 150 Kelvin in 1 liter? All right. So we need 1 mole. We need temperature needs to be 150 Kelvin. Oh, that's the very end. And we need 1 liter. So we need to change the liters. That's asking what pressure is achieved. So if we look at our formula here, it already calculated it for us. We didn't have to do any math today. But we can see 1 mole, okay, times the ideal gas law, which is R. We need that. That's always the same. Your temperature is in Kelvin, okay, and then your volume is in liters. So we got 12. So number 5 would be 12. Now, what's the unit for pressure that they're using? Because units are always important. What does that mean? Right there. ATM. ATM stands for atmospheres. That's what we use in a lot of the formulas that we're going to have coming up. All right, let's look at number 6. What pressure is achieved for 0.5 moles of helium at 150 Kelvin in 1 liter? So the only thing that's different here is the mole. So we're going to change N. N is the mole. We're going to go to 0.5. And the same question, it's just the moles were different. Well, that's interesting. When the moles went down, what happened to the pressure? We had 1 and we had 12 ATMs, but at half a mole, we only have 6 ATMs, 6 atmospheres. So we can see in the formula, in the math that we did in this, and when the moles went down, the pressure also went down. All right. So we went through all 6 questions there. Hopefully you got those typed in and submitted to Canvas. I'm going to go ahead and put those questions back on the screen. And then when you're done with the questions, we'll have a little time to kind of get started. Reading, we're going to go through and show you how to read in the gas laws assignment.